Our next problem says 4 consecutive numbers whose sum is 90. Let's go back to the first one. What do we have to do? Make a let statement. So let's identify what we're going to have our let statements be. So we're going to say let the first number be equal to n. Let's use n to represent number. All right, if n is going to be our variable, I want consecutive numbers. It doesn't say consecutive even, it doesn't say consecutive odd, it just says consecutive. So we need the let our second number be equal to n plus 1, okay? And remember, we're only adding 1 because if I do this on the number line, all I have is 1, 2, 3, 4, etc. All right, our next one, because we have 3, 4, let the third number be equal to n plus 2. And then the last one is going to be let the fourth number be equal to n plus 3. Okay, so we have 4 let statements. The first, the second, the third, and the fourth number. Now that we've identified this whole part right here, 4 consecutive numbers, we identified all of that. Whose sum, what does the word sum mean again? Sum means add. And the word is, what did the word is mean? That was a operation word too. That means equal to, okay? So now let's go and replace 4 consecutive numbers with all of our let statements. So we have the first one, n. Sum means addition, so plus. The second number, n plus 1, right here. Plus, because it says sum. Our second number, n plus 2. The sum of, so add the next one, n plus 3, is equal to 90. So there is our whole problem written out. Okay, so the next thing that we have to do, when you have an equation like this, every one of these n's has a first power, and remember that addition, you can add and subtract like terms. So I have an n, an n, an n, and an n. They're all to the first power, so I can put those together. So let's do that. I have 1, 2, 3, 4. I have a total of 4 n's, so I just put those together. Okay, then I have some constants that are also over here, like terms, constants. We're going to add all those together. When I add all those together, 1 plus 2 is 3. 3 plus 3 is 6. And then I bring the 90 down because I haven't used it yet. Now I have a basic two-step equation. So in order to solve this basic two-step equation, the first thing I have to do is get my constant to the right so he can match up with the other constant that's there. So I'm going to subtract 6 from both sides because that's the opposite. Bring down 4n because I haven't used it yet, and 90 take away 6 is 84. So now I'm down to that one-step equation. So again, I'm fixing to move up here since I write big. So I have 4n is equal to 84. My opposite operation is 4. So I'm going to divide that, and I get 1n is equal to 84 divided by 4, so that makes 21. Okay? So I got n is equal to 21. That's an answer. Good job. Remember at the very beginning, the last thing I said to do was reread the problem to make sure that you answer everything. Find all of the numbers. So look right here. N is equal to 21. That found my first number, true. Okay? So the first number is 21. but it didn't find the rest of my answers. So what I have to do is I have to go do n plus 1. 21 plus 1. So 21 plus 1 is 22. There's 2 answers. I got 2 left. N is 21, so that would be 21 plus 2, which would be 23. And then the last one would be 21 plus 3, which makes 24. So there were 4 answers that I needed to find. I found all 4 of them. How could I check myself? Well, to check yourself, it says that these numbers add, because sum means add, they add up to 90. So what could you do? You could add all the answers that you got. If I had 21 plus 22 plus 23 plus 24, and I were to add all of that together, let's see what we get, okay? That would be 4 plus 3 makes 7, 7 plus 2 makes 9, 9 plus 1 makes 10. So put the 0, add the 1 up there, and then count by 2s. 2, 4, 6, 8 plus 1 makes 9. So I did it correctly because I got the answer that I was supposed to. All right, come back and we're going to do one more kind of application problem.